Welcome back. Today we're diving into radical equations. So basically all a radical equation means is that it's an equation that has its variable inside of the root. Okay, and solving them is kind of like solving other equations that we've seen. All right. So the first step to solving a radical equation is first you have to isolate that radical term, right? You saw this too back when we did absolute values. We did the same thing, right? You wanted to isolate that piece of your equation. After that, you want to raise both sides to the power of the index, okay? So what that means is for a square root, you'd want to square both sides. For a cube root, you'd want to cube both sides, okay? So whatever power undoes that root, you would do, all right? Solve the resulting equation for x, all right? So obviously, once you do all of that, you want to solve it for x, and then always a good idea to go back and actually check your solution, okay? Make sure your solution works back in the original equation. So let's just dive right in and see how this works. So the first thing I'm going to do here is isolate my square root. So to isolate the square root means subtracting that 3 off. Okay, so I've isolated my square root. Now I need to square both sides, right? Because squaring is going to undo the root. So when I square it, it undoes the root, and then I get 25 on the other side. Now I'm just going to solve it for x, okay? So I'm going to add the 3 over and divide by 2. Just like that. And that, of course, like I pointed out, is always a good idea. You can go back and you can check that this actually worked. All right, so I'm going to toss that 14 in, and I'm going to check that it actually solves this equation. So 3 plus 2 times 14 is 28, minus 3 is going to be 25. Square root of 25 is 5, and my equation does check out. Okay, so that 14, I'm now convinced is my answer. When I plugged it in, it worked out perfectly. So let's talk about the other one. So again, the idea is I need to isolate that square root first. So in this case, that means I'm going to divide both sides by 4. So I have the cube root of x minus 5 equals 2. Once your variable is isolated like that, now I need to undo the root. So it is a cube root, so that means that I need to cube both sides to undo the root. That's going to break this free, and 2 cubed just gives me 8. Add 5 over, and I get x equals 13. Then, of course, again, like I already mentioned, it's a good idea to go back and check that that actually worked. So cube root of 13 minus 5, well, that's going to be the cube root of 8. So the cube root of 8 is 2. Oh, so you get 8 equals 8, and that does actually check out. So again, now that I've checked my work, I am convinced that 13 is the right answer. Okay, so again, always a good idea to do that. And then you may be wondering, well, what if I have the radical on both sides? Now, this is something, again, you saw back in Expo, so I'm hoping that it's pretty obvious to you that what you want to do here is I can make both roots disappear simultaneously if I just square both sides, because both sides are going to be free from their root then. So now that both sides are free from their root, Now I can just solve that linear equation. Get my x's together. I'm going to subtract x from both sides. So I'll have x equals 7. And again, let's check to convince ourselves that that's right. So I'm going to plug 7 in. So 2 times 7 is going to be 14. 7 plus 7 is 14. And that checked out. So I know that I have the right answer. All right, so that's how you deal with basic radical equations. Now, of course, when dealing with the radicals, the other thing that can arise is what about we have fractional exponents? Okay, so fractional exponents are again the same thing as radicals, but we need to be careful when we're working with them. So when we're solving something that has rational exponents, when we do that, we make sure when we do that, we need to use the reciprocal power to cancel the current one. So what I mean by that is, here, the first one I have x to the 3/5 equals 8. So to undo that power, I'm going to use a 5/3 power. Because remember, when you're multiplying a fraction times its reciprocal, that is actually going to cancel off and just leave me x. Okay, so for fractions, that's what you do. To cancel the fractional exponent, you're going to need the reciprocal. So 8 to the 5/3. Now here, I'm going to show you a neat trick to kind of help make it easier in this lesson for you to do that. So 8 to the 5/3, you can actually use your calculator to do that for you. 8 to the 5/3. Oh, 5/3. If you actually just type that in the calculator, it will actually do it for you. Okay? So I'm going to give you that as a little piece of advice that you can use that feature of the calculator, okay? If you just have a number to a power, just type it in and boom, it'll give you the answer. So here, 8 to the 5/3 gives me 32. Now, of course, always a good idea to go back and check in the original equation. So, in the original equation, let's plug this in and check. Let's see, 32 to the 3/5, is that actually equal to 8? So, again, let's go check it in the original equation. So 32 to the 3/5, oh, I'm sorry, I'll start over. 32 to the 3/5 power. And if you notice, that does actually check out. So that is my solution, okay? X does in fact equal 32. All right, so let's just keep working a little bit with these. So again, whenever I see this, I need to think reciprocal power. So here, it's going to take 7 over 1. Well, that's really just to the 7th power, right? 7 over 1. So here, I can use that 7 to cancel off all of that. So that's going to break free the x plus 5. And 3 to the 7th power, I obviously don't expect you to have that memorized. So 3 to the 7th power is 2,187. 2,187. And now let's subtract 5 to get our x. And now that we have our answer for x, again, is always a good idea. Let's go back and check that that actually worked. All right, so let's go and plug that in. 2182 plus 5 to the 1/7 power. Let's see if that actually equals 3. So let's go back and let's plug that in. So 2182 plus 5 to the 1/7 power. And I do get my answer of 3. Okay, so I am convinced that I have the right answer. For this next one, again, just like when we were doing radicals, the idea is you need to isolate the or the expression first. So I'm going to divide by 2 first. So x minus 2 to the 5/3 equals 32. So you need to isolate it first. So I divide that 2 off. Now I'm going to use the reciprocal power, okay? So here to get rid of that 5/3, I need 3/5. So that's going to break free the x minus 2, 32 to the 3/5. Again, feel free to use your calculator for that. 32 to the 3/5. So that's going to give me an 8 over there. So x minus 2 equals 8. So I'm going to add 2 over. X is going to be 10. And then, of course, I do want to get in the good habit of checking my work. So I'm actually going to go back and plug that in to see if that does, in fact, give me the 64 that I started with. So let's check all of our work. So 10 minus 2 to the 5/3. So I type that in, and it does give me the 64 that I started with. So I am convinced that I have the right answer. Okay, when I checked my work, it checked out. All right, now it does get a little bit trickier when you have to take an even root. Okay, so let's talk about what that means. All right, so remember, if you have something like x squared equals 49, when you square root it in the equation, remember that was taking a square root, so you always ended up with a plus or minus. Well, the same thing actually happens here. Okay, anytime you take an even root, it means that you need your plus or minus. So let me show you what I mean by that. Okay. So first off, we need to follow the same rules that we did before. So we need to isolate the rational exponent expression. So what that means is I'm going to add the 3 over. So I'm going to have x plus 7 to the 2/3 power equals 25. So now that the rational exponent is by itself, now I'm ready to undo the fractional exponent. To undo the fractional exponent, I need the reciprocal. All right. Now, that's going to break this free, but now I want you to think what's happening. 2/3 or a 3/2 power. So remember, whenever you have a power on the bottom, power on the bottom is a root. So in this case, I'm essentially taking a square root when I use this power. Okay, so by using this power, again, if I am square rooting in this equation, that means I'm going to end up with that plus minus relationship. Okay, so that's the little nuance you have to remember to this. Is whenever you're taking a fractional exponent, you're using it, and the bottom is even, you're taking an even root. And that means you're going to ultimately need your plus and minus. Okay, Now, what is this one giving us? Well, 25 to the 3 halves. Let me just show you what that is. 25 to the 3 halves power. That's giving us 125. So what that means is right now, I really have two equations happening. X plus 7 is 125. X plus 7 is negative 125. So here x equals 118 and x equals negative 132. So it is very important to remember that plus and minus. And again, it only happens when you're dealing with positive things in there. So let's go back, and of course, good idea. Let's go back and check both of these answers, okay? So I'm going to plug both of those back into my calculator. So I'm going to start with 118. So 118 plus 7 to the, I'm sorry, I need to remember the power, to the 2/3 power, then minus 3. When I do that calculation, I should get 22. Okay, and I should get the same thing when I use negative 132. So I also type that in. Oh, and that checks out as well. So again, it's super nice to go back, check your work, make sure you're getting the right answers here. So let's move on to our next one. So again, same thing. First thing is I want to isolate that piece of my equation. So I'm going to subtract the 3 and I'm going to divide by 2. So I isolate that rational exponent. Okay, and now to get rid of it, remember I need that reciprocal. All right, so here it's going to cancel off there. So I have, oh, don't even need the parentheses anymore. So x minus 4. Now here, notice the bottom is odd. So I'm taking a cube root. So here, again, goes back to those original ones I was doing. This doesn't concern me with the plus and minus. It's only when the root piece of that is even. Okay, so here I'm still good to go. I just take 27 to the, oh, to the 4/3, and I get 81. Add 4, and we get 85. And then again, always a good idea to go back and let's check that that actually worked. So I plug in 85. Oh, plug in 85 to the original equation, and I just want to check plus 3 at the end. And it does work. It gave me that 57 that my equation started with. All right, so here, let's quickly talk about what happens in these circumstances. Okay, so here again, the key first is I need to isolate that root piece. So I'm going to subtract 1. And divide by 3 to to get that. All right, so right now, that's what I have. Now this one looks weird because it has a root and it has a power in it. So the interesting thing you can do is you can actually handle both of those pieces. So if I want to undo the root, okay, remember to undo a root takes a power. Okay, so I'm going to use this fifth power to cancel the fifth root. And now 8 to the 5, that's going to be a huge number. 8 to the fifth power, 32,768. 32,768. And now you should know to undo a cube, well, to undo a power takes a root. So now I'm just down to the x plus 1. And now I need to cube root that big number. So cube root, if you remember, is in your menu here. So 32,768. Cube root that to get 32. Subtract 1. And boom, you have your answer. Now, because this video is running a little bit long, you could go back, plug that in to check it. I'm not going to do that because I don't want to take up a ton of time because I know that we're running a little bit long here. But the idea of that one is you can use powers to undo roots. You can use roots to undo powers, okay? Kind of the big idea of that one. And this one. So this one, I'm actually going to move that one piece over. Okay, now you may think that that's a little bit weird, but what is a 1/2 power? Well, a 1/2 power is just the same thing as a square root. So if you think about it like this, we already talked about how to handle that, right? We talked about now I can square both sides. I can square both sides to set that free. And now I can subtract x from both sides. And I can add 3. And once again, now I have my solution. And for this one, again, idea being you could go back, plug that in to check it. However, I'm not going to take the time because we are running a little bit long. So let's jump down to our word problem, and then we'll use that to finish up. So for meteor crater in Arizona, the formula d equals 2 to the cube root of v over 0.3 relates the diameter d of the rim in meters to the volume v in cubic meters. What is the volume of meteor crater? So here, the first thing we need to keep in mind is telling me that I need to use meters in this formula. Right now I have kilometers. So I need to convert that 1.2 kilometers is going to be 1,200 meters. Okay? So here is saying that it has a diameter of 1,200. And I want the volume of that thing, all right? So here's a practice of back to the originals of how do I solve a radical? Well, first thing we need to isolate it. So I'm going to divide both sides by 2. And now to undo the root, I'm going to have to cube both sides. So 600 cubed, 600 cubed is that huge number, all right? So let's see, 216,000. So 216,000 equals V over 0.3. Now to get the V by itself, now obviously I have to multiply that zero point 0.3 over. So now I'm going to multiply that by zero point 0.3, and there we have it. So its volume is 64,800,000 meters cubed. That's going to be the volume of that crater. So thank you so much for joining me. I'm sorry this one got a little bit long. There's just so much good stuff to talk about in here, and I wanted to give you exposure to all the different types of problems that can arise. So please make sure that you write your summary for this. Thank you for sticking it out, and come back tomorrow ready to do your practice work.